place value and decimals. First thing we're going to get you guys to do, we're going to get you to jot a little dot point about the decimal point itself. So the decimal point is just used to separate the whole number part of a value from the fractional decimal part of a value. So that's the point of a decimal point. Alright, they do actually have a point, that's why they call it a decimal point. Alright, what we're going to do next is we're actually going to do a little bit of a table, so you're actually going to need a ruler out, so grab your rulers out. Alright, so we're going to be doing up a place value table. We've got an example number here of 428.357. Okay? Please, please, please don't say it's 0.357 because it's really, really not. Okay? It is 357. Okay? If you call it 357, you're like it's giving it place value that it doesn't actually have. Okay? So it's really important that we just have these as individual numbers. We're going to draw up our table. It's going to have 7 columns. It's going to have 7 columns. Columns go up and down. First column is going to be hundreds. Alright, we're going to have our tens, our units. This one is our decimal point. Then we have tenths, hundredths, and thousandths. Okay, so there are our columns. And we're going to have, we've got one row here. We're going to have 3 more rows, so rows go across. Okay, all 3 of these rows are going to be to do with this example number. So, in this table, where am I going to put this 4? In the hundreds column. 2 obviously goes into 10, and then the 8. We have our decimal points. We have our tenths, which is 3, 500ths, and 7 thousandths. This is one of the reasons why it's really important that we don't say 0.357 because it's not 357, is it? Are we all good with that as the place values themselves?
Yeah.
So if we remember back to when we did some other stuff on place value, how can I write this in more of an expanded sort of version, do you think?
400.
So 4, and we're going to go times 100. And we can do that for each one. So what will the 2 be?
2 times 10.
2 times 10?
Easy going.
What will the 8 be?
8 times 1.
8 times 1. Is a decimal place. This one's going to be a little bit trickier though. 3. What do you think it's going to be? Anyone? 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 Anyone?
Nope.
No? Yes? Got it? No?
3 divided by 10.
Kinda.
3 divided by 1.
No, it's closer to the 10 one. So what we're going to do is still have times, but I'm going to call it 1 over 10. Okay, because that's what its place value is, 1/10. Alright. What can we do then if we've done this with the 3? What can we do with the 5?
1 over 100.
1 over 100, exactly right. Draw that right. And who thinks they can do the 7 based off of that? 1 over 1,000. Good, excellent. Yeah? So is that cool? Yeah?
Yep.
And there's one more way we can write it that makes sense with terms of place value, just to give us an idea of how things are working. What do you think it might be?
Like 400 in 1, and then 2, and then 20, and then 8,
7.
and then...
Alright, don't forget our decimal point. Got to make sure we keep that decimal point in there. What do you think I might be able to do with the 3? What do you think I might be able to do with the 3?
0.003.
No, we're gonna keep the fractions in units. Because it's 3/10. Yeah, 3/10. What about the next one? 5/100. And the last one, 7/1,000. Good stuff.
Me, shouldn't it be for like 5/10? Shouldn't it be 50? Oh no.
Yeah, it's still going to be 5 because it's 5 hundredths. It's not 50 hundredths, it's 5 hundredths. And then 7 thousandths. 3/10.
Sorry. Alright, I'll get that.
Okay. Are we okay with that as a concept?
Yeah.
Yeah, we can sort of understand how that works.
Yeah.
Yeah?
Sure can.
Alright, let's have a look at a couple of example questions. There's our first one. What is the value of the 8 in the following? We have 12.85 and 6.1287. So, for the first one, what is the value of the 8? What is the value of the 8? 8 tenths. Okay, it's 8 tenths. Does that make sense?
Yeah.
It's in that tenths column, so it makes it 8 tenths. What would happen if it was further down along here? What do you think the next place value might be? Tens of thousands, and then hundreds of thousands, etc. Okay? So what then does that make the second one here? What's the value of the 8?
8/100.
8. So we've got tenths, hundreds, thousandths. So it's going to be 8 thousandths.
Yeah, that one.
Or, how can I write it?
8/100,000.
8/1,000. Okay. For this question, we're going to do some changing around. Okay? We're going to change some fractions into decimals based on what we know about place value. Okay, so there's our 3 numbers. We have 7/10, 5/100, and 3 and 17/100. So the last one's going to be a little bit tricky. What do you think we can do with this one? Based on what we know already. 0.7. That's pretty easy, hey guys? We know that it's 7 tenths. There's no whole numbers in front of it, so we're going to have 0 whole numbers. 0.7 tenths. So it'll be just 0.7. Or 0.7, I should say. What about the next one? B, 5/100. 5/100.
0.05.
0.05, because again, exactly right, no whole numbers, so we're going to have 0. There's nothing in the tenths column, is there? So we're going to have 0 in the tenths column, and then we have a 5 in the hundredths column. Alright, any questions so far? Cool. Last one. Who thinks they've got the last one?
3.17.
3.17. Perfect. Excellent work. Alright, why is it 3.17? Well, we've got 3 in the whole number section, don't we? We have 3 whole numbers. So we need a 3 before the decimal point. We have 17 hundredths. That means we have 7 hundredths and 1/10. Because it goes a bit backwards this one. So it's going to be 1/7. All good?
Yeah.
Question?
Can I do the question, please?
Yes. Alright, so that's how that all works. Okay. which of these numbers over here out of these two do you think is actually larger? 0.7 is the larger one. So it's a little bit different to how we would normally say it. So 5 is obviously smaller than 7. 50 would be bigger than 7, but because it's going the other way, 0.7 is bigger than 0.05. Okay?